Hi everyone, this is your maths for today. Going back to fractions. So last week we did a few lessons on adding fractions. We did a few lessons on subtracting fractions as well, but that was the area we wanted to go over again. So we're hoping today will go a lot better for you. So let's have a try. There's a couple of examples here, but let's go through some together. And this is what your worksheet is going to look like. Very similar to the other day, but as I say, with subtracting fractions today, not just adding. So let's look at some examples together. So a lot of the process is very much the same as you were doing before. So we've got 4 and 5/12 take away 3 and a quarter. So the first thing you of course notice is that the denominators are not the same. So we're going to make them the same. So what can we do to make them the same? Well, we can make quarters into 12s if we can count up in 4, 8, and 12 to make them the same. So let's do that. So let's keep the 4 and 5/12 the same. Subtract 3 and how many 12ths? Well, to make 4 into 12, we had to multiply by 3. So we have to multiply this 1 by 3 as well. And 1 times 3 is, of course, 3. So now we've got 4 and 5/12 take away 3 and 3/12. This is a lot more straightforward. I'm hoping it will sort of cry out the answer more likely to you. So first thing we can do is subtract away our whole numbers. 4 take away 3, of course, is 1. And then 5 take away 3 is 2. So 5 take away 3 leaves 2/12. Now, one of the other things we want to be doing today is looking out for moments where we can simplify the fraction. Are we saying it in the simplest possible form? 1 and 2/12. What do you notice about 2 and 12? Hopefully you've already shouted at the monitor that they are both even numbers. If they're both even, we can at least halve them. So if we did, we'll keep our whole number the same, of course. We're going to divide the 2 by 2 and we get 1. And we divide the 12 by 2 and that gives us 6. So it's the same fraction, but in its simplest form. So let's look at an example of how you'll do this in your work. I'm going to give you the example actually of the of question 12 here. So let's do 12 together. So we've got 4 and 7/8 subtract 1 and 5/16. Now, these first few questions are actually giving us a bit of a clue because they're telling us we need to have this in 16ths in our final answer. So the first thing again we notice is the denominators are not the same. So I'm going to wait for a second. Maybe you can pause the video if you like. See if you can complete this one yourselves. So make them into the same denominator. My feeling is that, well, 8ths could become 16ths. So can you take them and put them into the same denominator, and then can you carry out the subtraction yourself? So pause the video now, have a try, and then restart the video, and I'll go through the answer to that one with you. Okay, if you're watching this, I assume you've already given this one a try, so let's go through and see how you did. So we're going to keep the 4 the same, the whole number. 8, we're going to turn into the 16ths. And we're going to turn the 1 and 5/16ths. We're going to stay the same because we're staying in 16ths. To make 8 into 16, what did you have to multiply by? Hopefully you're shouting 2. So that means we have to multiply that 7 by 2 as well. So this becomes 4 and 14/16, take away 1 and 5/16. So now we subtract our whole numbers. 4 take away 1 is 3. And 14 take away 5 Remember, we're saying 16ths. 14 take away 5 is 9. Let's check if they can be simplified. Can anyone think of any times tables that they are both in? Well, they're not both even, so they're not in the 2s. 9 is in the 3s, but 16 isn't. 16 is in the 4s, but 9 isn't. Neither are in the 5s. Looks like we have to stop there. So that is as simple as that fraction gets. So our answer to go for question 12 would be 3 and 9/16. If you don't want to write on the question sheet, of course, you could have written 3 and 9/16. And that gives you the answer. So I'll leave that one there for you as an example of an answer and how to form it. All right. Now we're going to move on to something different. So let's come back to my example page. What we need to be on the lookout, unfortunately, is that when it isn't always as easy as that. And I'm going to show you what I mean. So let's get my red. So the first thing we need to do, same again, the denominators are not the same. Let's make them the same. So 2 1/4 subtract 5/8. Well, you're probably hopefully already shouting that you can make quarters into eighths. So let's do exactly that. So I'll keep my 5/8 the same. And instead of it being 2 1/4, it's going to be 2 and how many eighths? What do you have to multiply 4 by to get eighths? You have to multiply it by 2, of course. So that means we have to multiply the 1 by 2 as well. And 1 times 2, of course, is 2. So now we've got 2 and 2/8 subtract 5/8. I wonder if you can spot the problem. I wonder if you can see what the issue is. This number, the 5, the fraction we're subtracting is larger than the fraction we're subtracting from. So this is a problem. So what we have to do in these instances is convert the fraction to improper. So to convert to improper, you multiply your whole number by your denominator. So 2 times 8 is 16, and then you add your numerator. So 2 times 8 is 16, add 2 more is 18, and we keep in eighths. And now we're going to subtract 5/8. And now hopefully you can see that that is much simpler to do. 18 subtract 5 leaves 13/8. Quick check, is that as simple as you can make it? Of course not. We can now convert back to mixed number. So if you did 13 divided by 8, you should get 1 remainder 5. So that is what we go back to mixed number, 1 and 5/8. Check now to see if it's as simple as it can be. Well, 5 is in the 5 times table, but 8 isn't. 8 is in the 2s and the 4s, but 5 isn't. Neither of them are in the 3 times table, so that is as simple as that one gets. So the final answer for that one is 1 and 5/8. As always, guys, please remember you can rewind this video, go over that example as often as you like until you feel that you understand it as fully as you should. But here's another example that I'm going to give you an opportunity to try out for yourselves. All right. So I will start you off, and then I'd like you to have a try for yourselves. So the first thing we spot, as always, denominators not the same. So let's make them the same. Can I make twelfths into quarters? I could. I could divide it by 3, but I can't divide 5 by 3. So that's no good. So I'm going to have to make quarters into twelfths. I'm going to have to go up, and that is completely fine. So instead, I'm going to get 6 and 5/12, because we're going to stay in twelfths, subtract 4 and some twelfths. So what did you have to multiply the 4 by to get 12? You times it by 3. So that means we have to times 3 by 3. And that, of course, is 9. Let me just get rid of that circle, sorry. There you go. So we've got 6 and 5/12, take away 4, and 9/12. Now, hopefully, I'm hoping that you're seeing that this example has the same problem as the one before. The 9 is bigger than the 5. The fraction we are subtracting is larger than the fraction we are subtracting from. So what I would like you to do in a second, you're going to pause the video, try your best to convert them into improper fractions, and then complete the subtraction. When you get your answer, put it back into mixed number. Once it's in mixed number, is it in as simple a form as it could be? Okay, so pause the video now and see if you can complete that one. All right, if you're watching this, then I will assume that you've had a go for yourselves, and we will carry on. So we're going to make these into improper fractions. So we're going to do 6 times 12 first, and then we're going to add 5. So 6 times 12 is 72, plus the 5 is 77 twelfths. Subtract. 4 times 12 is 48, plus 9. 48 plus 9 is 57 twelfths. So now we can definitely subtract. If you weren't sure, if doing this in your head would be a problem, then it's fine. Just use your column subtraction. 7 take away 7 is nothing. 7 take away 5 is 2. So we're left with 20 twelfths. That is an improper fraction. So our next job is to convert that back to mixed number. So 20 divided by 12 will give you one group and a remainder of 8 twelfths. And now last job is that as simple as it can be. 8 and 12. They are both even. What times tables are they in? They are in the 2s, and they are both in the 4s. They're not both in the 6s, so we'll stop there. So the easiest thing to do, or the quickest thing to do, is to divide them by that highest common factor, which in this case was 4. So if we divide them both by 4, we'll keep the whole number the same, of course. So we'll divide by 4 up here. 8 divided by 4, of course, is 2. And 12 divided by 4 is 3. So 1 2/3 is your final answer. Okay. Right, I'm going to offer one more example. If you think you're comfortable with this now, then of course you're welcome to start. But if not, here is one more example for you. And we're going to do 12. And remember, with all of your work, we're going to try and show the answers in simplest form and mixed number. That's the end result that we're looking for. So let's try this one. And I'll give you a chance to pause the video and see if you can complete it. And I'll go through the answer with you. So 4 and a 9th, take away 2 and a 3rd. So of course, I'm sure you're shouting at the screen now that there is no common denominator there. So we need to find one. So what I'd like you to do, pause the video, try your best now to make the denominators the same. If the fraction you're subtracting is larger, convert to improper, like we just did in the previous example, and then subtract, and then convert back to mixed number, and then see if there's any way of simplifying it. So go ahead and pause the video now to try that question yourself, and then I'll go through the answer with you. All right, if you're watching now, I'm hoping you've had a chance to try this one yourself, but let's see how you did. So of course, 9ths and 3rds, they're not the same. So we can't make the ninths into the thirds in this case, so let's make the thirds into ninths. So we'll keep our 4 and a ninth, subtract 2 and some ninths. So how did you make the 3 into 9? What did you multiply by? 3, of course. 3 times 3 is 9. So 1, we have to do the same to the top. 1 times 3 is 3. Hopefully you spotted that the problem here, 3, oops, let me just get my different color so make that nice and clear. Oh, sorry, pen's playing up, never mind. Hopefully you can tell. So the 3 here is bigger than the 1 here, so we have to convert to improper first. That's the first thing we have to do. So 4 times 9 is 36. So 4 nines are 36. Add the 1 is 37 ninths. Subtract 2 times 9 is 18. Plus the 3 is 21 ninths. Again, if you're not sure, if you can do that in your head, fantastic. If not, you can always get your column subtraction going. 7 take away 1, of course, is 6. 3 take away 2, of course, is 1. So that leaves us with 16 ninths. That's improper, so let's put it back to mixed number. 16 divided by 9 would be 1, remainder 7. So we'd have 7 ninths left over. And then the question becomes, is 7 ninths as easy as it is, as simple as it gets? Well, 7 is in its timetable of its own, so it doesn't look like this one's going to go any further. So the final answer would be 1 and 7 ninths, or if you prefer to use it in the text tool, then 1 and 7/9. All right. Okay, I'll leave that final answer example there. There are a couple of the examples we've already been through are here, trying to give you the steps of how to work it out, being on the lookout for simplifying, being on the lookout for when the fraction you're subtracting is larger than the one you're subtracting from. Any problems, please use the J2 message and get in touch with us. Otherwise, guys, good luck, and we'll speak to you later on. Take care. Bye-bye.